Now, once we have fixed the problem and we've identified all the particular issues that were out there, we need to go back and do what is called a root cause analysis, or RCA. The primary purpose of the RCA is to analyze a problem or sequence of events in order to identify what happened, why it happened, and what can be done to prevent it from happening again. So basically, this is that after you do the whole software development cycle, you go back and you do that review process. You go back in and review what went well, what didn't go well. But here, for a root cause analysis, we need to look at this from an end user's perspective and a risk analysis. So we want to make sure that we've defined the problem correctly, that we gathered all the information that came out of not only identifying the particular problem, how we can reproduce the problem, and what we did to fix the problem. So we get all that information. We identified the causal factors. These are the things that actually triggered what happened. So now we have our data in hand. We want to look at all the different possibilities that led us to this problem. Was it an alphanumeric field that really should have been alpha only or numeric only? Did we have bad data? Did we have bad security practices? Were we missing logins? Were we missing role-based security? Once we have identified the factors, we can then determine the root cause or causes. And here we use some of the root cause analysis tools that are on the market. We can also go in and just kind of dig through what happened. What did we do to actually fix the problem? So this could determine the root cause is a combination of what the developer or networking teams or the different groups went in to figure out. We take how we figure out we have the bug, but then what did we do to fix it? Now that we found the bug, how did we fix it? And then the last one is, okay, now that we fixed it, now that we have things stable again, what can we do to prevent this from happening again? What is the recommended and implemented solutions going forward that we can put in place to stop the bleeding? Make sure this doesn't happen again. So there are different things you could do. This could also be training. This could also be implement additional tools, add additional logging, add alerts to your system, add system monitoring. Those different agents you can put on your PCs. These are just some of the things that you can do at the end for the root cause analysis to make sure that everything is cohesive, that you have identified what's going on and what happened and how you can prevent this from happening again. People are going to be asking why this happened. Now, as a developer, or depending upon where you're at in the company, if you are constantly asked why something broke, you're going to start getting defensive. And with the root cause analysis, you have to try to detract yourself from that. Don't take this personally. If you make a mistake, own up to it. Say, hey, I made a mistake in this process, or the code had this particular problem in it. Here's what happened. This is not a blame game. This is basically a cause and effect. What caused the issue, what was the effect, and how do we prevent it from happening again? When you're doing a root cause analysis, try to take the emotions out of it. I know it's hard, but the RCAs are very critical to ensure that you do not have problems in the future. And the only way to do that is to really be honest when you do your research here and you actually go through and do the analysis and identify what happened. Finally, before we leave this page, the last thing I recommend from an RCA is, even though you've done the RCA, even though we've identified all these things, the recommended and implemented solutions are identified, I also recommend you implement some type of training practice. Training could be a part of the recommendation, but if you have a production support, customer support, it's still good to do either monthly trainings depending upon your release cycles, or at least once a sprint or once a release cycle. You definitely get your support teams involved so that they get the training on what's coming, what are some of the issues that have been found and identified. If you're on the support side of things, I definitely recommend that you do at least monthly, if not quarterly, review of all your RCAs to make sure that you don't see a pattern. Do we see a bad pattern in our software? Are things breaking? What is going on? And that can also help you identify root causes in organizational problems, strategies, release cycle problems, development problems. So RCAs give us a lot of information. And from that, you want to add additional things like training. Lastly, I want to leave you with avoid firefighting. So when we get into this routine of software support and production support, customer support, we get through fixing problems, we potentially run the risk of getting into a firefighting mode. Basically, every time a customer calls, has a potential problem, we go out and we quickly fix it. So all we're doing is hot fixes. We're not going through a normal software process. So in a sense, firefighting is just, it says here. So firefighting is just like a real world where the assumption that a fire or where fires are unpredictable and that they may be dealt with immediately or have to be dealt with immediately. Again, hot fixes. If this tool is used too frequently, we end up in like an emergency action mode all the time. And this could lead to poor planning, lack or organizational support, and is likely to tie up all of our resources that could be used elsewhere. Now, to keep firefighting to a minimum, a comprehensive disaster plan might be implemented. We could think about if something critical happens, how do we address that as a company? Do we have things like failover? If a system goes down, are we in a load balancer? If one machine goes down, we just take it out of the cycle and put another one in. So there are things that can be done to help prevent the firefighting model. However, I've actually been in this situation currently where firefighting, unfortunately, can be a necessary mode to go into for a while when you're dealing with some critical issues. For instance, if you're dealing with a legacy application that is so old, you have no one left in the organization to support it. You have very high technical debt. No one knows how things work. System is unstable. You can't even go back and patch the software anymore. It's that old. Or you could be running into unexpected side effects of a code change or an incomplete software deploy that went out to a system incorrectly. In these situations, you potentially could end up firefighting where you're just constantly, you get one issue fixed, another one rises. You jump to that one and another one. And it's just repeating pattern that you don't want to get into. Yes, in some situations, you're stuck here. However, you still want to step back at the end of every hot fix or the end of every bug fix and say, hey, do we have an understanding of what is causing these issues? Did we do our RCA? If we did our RCA correctly, we should start to see a pattern and be able to identify what's causing this critical failure or these firefighting mode. And how do we get out of it? What is our path to get out of it? Because we need to make sure we have our resources freed up so that we can continue doing normal business functionality, get our software built correctly, and keep things moving out the door. So just to quickly recap, we talked about the overall process of production support. We talked about coming in at the customer support level, where the customer support rep talks to the customer, identifies what the issue is with the customer, what type of bugs or problems they're having. They get the people involved. They troubleshoot the type of problem it is. Is it customer facing? Is it internal, back end? Is it a configuration issue? Is it just simply the user forgot their password? We go through a troubleshooting process of walking through internally, trying to reproduce the bug, try identify what's going on. Again, don't panic. Take that breath. Don't take it personally. Keep it all on the level and keep everyone informed. We also talked about identifying the different types of risks, the risk analysis, validation, and the particular problems you can run into. We also talked about the different types of fixes we could do. We talked about the hot fix, fixing it real time, right now, doing normal bug fixing during our software development lifecycle, testing our code, finding bugs, fixing them, and preventing those bugs from going out in a release. We talked about maintenance windows, where we take the systems down for scheduled maintenance, where we do system patching, updates, system reboots, things of that nature. And then we talked about patching, where instead of doing a hot fix, we actually go through a very small release cycle where we fix a combination of bugs, get them tested, and then roll that out in a timely manner where we actually test it, not just quickly reacting to the customer complaint, to the fire. And then we talked about prevention, doing the root cause analysis, identifying what caused the problem, why it happened, and what can we do to prevent it. Training, better testing, things of that nature. And the last thing we talked about was avoid firefighting. Try not to get into that mode of always being reactive. We don't want to be in the mode of always doing hot fixes, just reacting to a customer's complaint. We want to be mindful and think through the process so that we make sure we're not adding additional bugs into the system and testing our software thoroughly. So with that, I will open it up for questions.
Mike, I had an production issue. Is that the most scary part for a software developer when it goes to production? Or is it deadline when you're going to go live? Like, what scares you when you roll the software to production?
One of the biggest things personally that I deal with going to production is, for the different fields I've been in, is healthcare and PH, patient health information or financial information. Typically, yes, deadlines are scary, but deadlines can come and go. They're an arbitrary number in some cases. Sometimes they're not, like when dealing with government healthcare laws. One of the biggest concerns constantly with any type of software development is data integrity, making sure that your data is not being exposed, that should not be exposed, and is being encrypted correctly. I've been in a couple of situations where PHI potentially could have been leaked. Thankfully, it wasn't, and we caught it in time. But that's the biggest concern, is when you have a release that goes out and something critically fails. You always, as a developer, fear that you missed something wasn't done right. Now, typically in larger software organizations, you have larger QA departments and there's a lot more testing involved. But when you're dealing with smaller startups or typically like just smaller software shops, you don't have that larger QA. So you don't have the time to necessarily do a full regression of your software. So when you make a code change, you don't know. There is that risk, especially if you have to make a hot fix. If there's a production issue, something's down, you fix it, you always have that nagging concern or fear. Did I break something else? Was there something else that we missed? Why did it go down? And that's why you want to do those things like that root cause analysis. I don't know from your perspective, Rob, what you would run into, but that's my perspective.
Yeah, the scariest thing actually among those, it probably is production issues, because you've got, and particularly with healthcare and something where you've got something critical. If it's an app that's, I don't know if it's like it was an Angry Birds app or something like that, where it's just people playing games or something that's for fun. And even if it's something where people are, I don't know, like if it was like a radio app or something where you're listening to a radio show or a TV show or something like that, it's not critical necessarily. But when you talk about something that is, it's either like the lifeblood of the business, where if it's not running, they're not generating revenue, or somebody's literal lifeblood where it's health and somebody could get sick or could die because of some bug or something like that. Those obviously are very scary. But outside of that, I think in general, it's actually the ones that probably are the scariest, most annoying or whatever. And this sort of goes to Michael's topic in general, are the ones that keep showing up. When you have something and it's fixed, whether you say it's fixed or you think it's fixed or somebody else that's on the team has fixed it, and then essentially the same bug appears again, it shakes your trust in whether it's fixed the next time around. And so it is one of those where it gets into and this gets to, so again, some of those steps Michael mentioned, where you really say, okay, let's step back. Let's look at this like root cause. What really causes? Let's make sure that this is something that when we fix it this time, we can actually fix it. Sometimes it is very much a case where you look at it and you say, oh, this is the reason that this bug occurred. And so we'll just change this thing and we'll be off and running. We're fine. But what you end up doing is it's more like you're putting a Band-Aid on it. You're not fixing it. If you don't look into it enough, sometimes you're correcting for the result and you're not fixing the actual bug. And so that can be really nasty, because what happens in some cases, you end up, you build this layer or infrastructure that corrects for this bug on multiple situations. Then you find out after the fact after you've put in several fixes and made these changes that, oh, those things really weren't needed. There was this other approach I was supposed to take. So now you get in the situation where you have your fix, and you figured it out, you fixed it, but then you have to go back and find all of those places where you made those adjustments to change for it and basically roll those back. Because what you were doing is you were doing this one-off kind of fix for these, even if you didn't know it, and now you've got to go track them back down, which also goes to the whole idea of version control and trying to keep good, which is very rare, good comments about, or at least a ticket, some sort of ticket number, which is more common that it's done as far as what that change was, what it was for. So in this case, if I had 15 tickets related to this bug in the past, now I go back and fix it and I realize I need to go undo those changes. I can go back to those 15 tickets and I can look at what was changed. I can look at those code commits, figure out what was changed, and roll it back. It's not fun. It's not pretty. It's going to be probably tedious and time consuming, but at least I can be thorough. I can actually look at it and say, yes, these are all the places I changed it, and this is where I need to roll them back. I did want to mention that I think the thing that I like that you mentioned there early on, Michael, is the don't panic. Obviously, there's the Douglas Adams thing that just jumps to people's mind, but it really is, I think that is the cause for stumbling into firefighting and stuff like that more often than not, is that there's this, we found a bug, we want to fix it immediately, and it's almost like a panic. It's almost like a rush to get it done. As you mentioned, we don't step back, take a breath, and say, okay, what really happened? What do we really need to do to fix it? And I think if you can keep a cool head, that is a huge first step in dealing with these things properly, so that you assess the problem, you figure out a solution, and you fix it once and you're done, as opposed to it keeps recurring.
And I guess on that, one of the things to mention is if you get into a firefighting mode and you're constantly doing hotfix, your code is eventually going to become spaghetti code because you're not taking the time to go back and review things correctly and go through the normal software process. And you'll run into the risk of, is your code reaching an unmaintainable or unstable place just from that continuous hotfix mode?
That's an excellent point. And it does make it, just the code itself makes it unmaintainable at times, because you get almost like the spaghetti of all these little patches and little things. But also, usually because you're doing this quickly, it's that whole firefighting mode. You're shortcutting some of the processes. So your documentation is not up to date. Your comments aren't up to date. You may have it, but there's a lot of cases where you see this really nice first version of code, and there were a bunch of fixes, and it just makes the whole thing a mess, because you can see where at some point it looked like it was done right and properly thought out and documented, and all the T's were crossed and the I's were dotted. And then you find these like jumbles of code. It's like, why is this here? Or you'll find magic numbers and all kinds of other just bad things showing up in the code that you started off great, and then because you didn't follow through and keep your head, you essentially ruined a good thing. Excellent point.
I would like to thank everyone for your time today. We appreciate your time. And if you'd like to discuss any of our topics further, you can reach out to us at info@developernerd.com. You can reach us on our website, developernerd.com/contact us. We're also on Twitter @developernerd. We're on Facebook, which we get that occasionally. We're at facebook.com/developernerd. We're also on Vimeo. You can find our videos on Vimeo. And we now have a new YouTube channel. You can Google Developer on YouTube and find our videos there. Our goal is making every developer better. Have a wonderful day.